Good day, everybody. My co-author, Maureen Huang, will do the presentation, but just in case, I'm doing this backup video. My name is Steed. So our talk is about this social economy association analysis for the 2020 presidential election with semi-covariance. So we do two things. One is semi-covariance. The second is we do some analysis of the president election in the United States, Biden versus Trump. So we're gonna go over three sections. First section, introduction. Second is mathematics derivation, and then we have our conclusion. So first part, we're gonna do introduction. So this part we basically explain what is a covariance. Covariance is the correlation between two variables. And if two variables are the same, then we have a variance. If you take this covariance divided by this standard deviation, which is the root of the variance, then you get a Pearson correlation coefficient. So this is a well-known Pearson. So in this paper, we basically extend the Pearson correlation into the semi-covariance, which means we're using the well-known function called the rectified linear unit, which is a selector for the AI, artificial intelligence neural network. So we're using these ReLU to select variables when it's positive. This way we divide a quantity x into up part, for example, y-axis, or right part of x in a Cartesian coordinate. And then we're using this ReLU method to analyze this Biden versus Trump. So for the American election 2020, obviously Joe Biden gained more vote. Trump lost this election, but sometimes they say not really. So vote are questionable. So in order to see whether the vote are questionable or not, we do this analysis to trying to back up the final result by doing the analysis of the voter of the states associated with the different economic factors. So let's first take a look at the Pearson formula. This is 1880, way back. So Pearson, he figured out a formula. So this is covariance, this is standard deviation. So because there are two variables, so you have to divide by standard deviation. For this Pearson coefficient, he calculated everything in one formula. So xi minus x, doesn't matter xi greater than x bar or less than x bar. The same thing for yi, doesn't matter it's greater or less. So he sum up all together, but in our case, we want to distinguish between the case when the xi are above x bar or when the yi are below the y bar. So this is basically what we do. Here, nothing can be changed because there's a square. So it doesn't matter below or above, you will end up the same value and then you take a root. But on the up part, when they are a different case or you got a different part. That's what we do to distinguish. We are not the first to do that. The first one is done by Harry. Harry is a UCSD professor. He won 99 Nobel Prize for economics because he did the discrimination between the upper part and the lower part for the variance, and he called the semivariance. However, we go further, do the same thing for the covariance, because the variance is only for one variable. Like if you look at the back, this is when x equals y, it becomes the variance. But for variance, you can also do upper part and lower part, or positive or negative. So that's what the Harry did. So we basically contributed in three things. First is following Harry's idea, we extend a semivariance to a semicovariance using the ReLU method. And then the second thing is that we look at the presidential selection, and then we do the analysis. So that's three things. And here's, let's take a back of the mathematicians. The first mathematician is Laplace. He come up with this expectation probability idea. And the second one is Gauss. And he come up with this complex plane, X and Y. And he also studied this Gaussian variance. That's why it's called Gaussian distribution. And then the last one is Mandelbrot. He come up with a fractal dimension geometry, where this semi-sense kicks in. When you have a fractional dimension and a fractional moment, you obviously will run into the complex plane. So that's the mathematics behind it. So the problem we're trying to solve is with the Pearson correlation. So if X and Y go like that, you're gonna have a correlation coefficient equals 1 if they fall in on this line, and you get the -1 if they're falling on that line. And if it's scattered everywhere, it's a 0. So 0.8 is something like that, -0.8, something like that. However, when your data is scattered everywhere, it's 0. This is not only one pattern. For example, we can have something scattered on the plane, go like that, still get the 0, or look like that, or this one, or that one, or even that one. They all end up with the 0. So in order to distinguish all these different patterns, we needed to extend this Pearson coefficient into semi-one. That way we can cut them into the different quadrant and calculate the correlation independently each other for the upper part and the lower part. So that's what we do. Here's how we using the ReLU to select the positive for X. And obviously, if you put a negative here, you select the negative part. So that's how we do it. So we split a variable z into the positive part and the negative part. So add them together, that's the whole part. And then you take expectation, and then you do the covariance, and then you divide them into positive, or negative, and then this is a positive, negative, positive. So basically, we divide these things into 4 different quadrants. And the first and the third, they are in the one group. And the second and the fourth, they are in the other group because one of them are negative. This one are both positive or both negative. That's what we do here. And then we can further divide by this variance, and then we got Pearson coefficient. So Pearson coefficient is actually the positive part plus a negative part, or minus absolute value of negative part. So we call the up part and down part. Obviously, when x equals y, the down part equals 0. However, the up part can be still split into the up variance and the down variance, because when they are equal, obviously they are correlated. They're gonna be positive and negative at the same time. That's why you only calculate the first quadrant and then the third quadrant. And that's what Harry of UCSD did, where he won this Nobel Prize with this formula. For the variance, you split into up part and the down part. In summary, we have up covariance, which is the first quadrant and third quadrant, and a down covariance, which is second and fourth. So that's a formula. We're using this formula to calculate the presidential vote for each state. So we have a Biden state or Trump state. As you can see, this one is Biden, California is Biden, and then the Florida is Trump. So each one have their own number of vote and also their state. So we take this number of vote of each state, and then we do correlation to the number of factors. For example, we do factors with NASDAQ, death toll, mental wellness, a number of scientists, or how many horses sold in that state. So these are 5 factors we correlate with the vote, number of vote. And here's the result. So for the Trump, NASDAQ is a correlated 0.08. This is up correlated. Kind of weak, very weak. And then this is a down correlated. That's the down part. This is the up part, 0.47. That's pretty strong. That means whoever kind of died, they actually are sort of concerned about Trump. And then this is the mental illness, number of physics, number of horse sold. And for the Biden, we did the same thing. So the Biden's vote for each state correlated with the stock market of each state, number of people died in each state, how many people are sick in each state, how many scientists in each state, how many horses been sold in that state. So we got the up part and the down part. And in summary, well, we can do the same thing with the Pearson correlation. So this is a Pearson correlation result. Pearson correlation is just one number. Our correlation has 2 numbers. So come to this conclusion, what we got is basically for the mental health is weakly related to Trump's vote. And then the same thing, the Steed cell is strongly related to Trump. So these people are on Trump's side. And for the NASDAQ, COVID deaths and scientists, they are strongly related to the Biden side. So basically, Biden are more related to the stock, number of scientists, and also the COVID situation. So basically, okay, I'm tying up. So basically, Trump basically got the one strong support, 1 weak support. However, Biden got three strong support. So in that, so we can conclude actually Biden is the one supposed to win, and there's nothing worry about the voting. And here's the data comes from, and we thanks Mr. Bin Jiang for help us format the paper. And that concludes my talk. Thank you.